welcome back. In this particular video, we will be discussing the problem find if one string is anagram of another string or not. We are given two strings S and T, and we have to do what? We have to write a function to determine if T is an anagram of S or not. That is, let's say there are two strings. First string is S, second string is T, or maybe let's say S1, S2. What we have to do is we have to check whether the second string is the anagram of first string. Now, what is an anagram? Anagram is not given although in the problem statement, but what are the anagram strings? The strings which are anagram to each other are nothing but if we are able to rearrange them and convert one string into another, then both of these strings will be known as anagram to each other. Example is, let's say the first string is anagram itself and second string is nagaram. So if these two strings are there, can we rearrange the characters of first string to make it become the second string? Answer is yes. So that's why the output is true. Why? Because if I will say N will come in the front, then A, then G, then A, then Ram. So it will become Nagaram. What about rat versus car? You can't rearrange rat to become car. Why? Because obviously in rat there is a T, in car there is a C. How can you convert C to T to C? Like you can't change the letter, you can't swap the letters. What you can do is you can just rearrange the letters and check whether the first string is anagram of second string or not. If first string will be anagram of second, second will also be anagram of first, because you can't just say that I am able to rearrange first string and make it second. You can also make it the second string become first string by rearranging if both are anagrams to each other. And what we have to assume is we have to assume the string will only contain lowercase English alphabets. It means the strings will contain A till Z letters only, and that too in lowercase, in small alphabets. So the point is how we can check whether two strings are anagram of each other or not. One easiest way is nothing but generating all the permutations, because rearrangement means permutation. That is, given rat, let's say, is the first string. Find out all the permutations of rat. Rat, RTA, then TAR, then TRA. Then similarly, you can say there will be ART and ATR. And now compare whether this string is equal to the second string or not, or this one, or this one, or this one, or this one, or this one. If any of the permutation is equal to the second string, then yes, both are anagrams, otherwise not. But this brute force solution, where we are generating all the permutations of the first string, will take order of n factorial time, where n is the number of characters in the first string. Because if there is a string of 3 letters, the number of permutations will be 3 factorial, 6 permutations, as I just wrote down. So we can't just generate all the permutations so easily. And even if we do it, it will be very time costly. It will take exponential time, almost order of n factorial time. Can we do it better? See, if I just compare these strings which are anagram to each other, anagram, nagaram, or maybe if I take, let's say, a string which is A, B, B, C, C, then E, E, D, D. This is the first string. And let's take the second string as A, B, C, D, A, B, C, D, E, E. This is the second string, let's suppose. Are these two strings anagram to each other? Answer is yes. You can just rearrange both of them to make them equal. So if I am able to rearrange the first string and make it become second string, or rearrange the second string become the first string, can I rearrange both the strings to a common place, and that common place should be easy enough to be figured out? And the answer is, if I am able to sort the first string, what it will become? It will become A, B, B, C, C, D, D, E, E. What about sorting the second string? Sorting means just rearranging all the characters in a sorted order from A to Z in increasing order. So second string will also become A, B, B, C, C, D, D, E, E. It means if the first string in some rearrangement becomes this string, second string in some rearrangement also becomes the same string. That is, sorted string first is equal to sorted string second. It means both these strings were anagram to each other. So one of the solution, better solution, not the exponential one, but in polynomial time, will be just sort both the strings using any inbuilt sorting function, which will be able to sort strings, and now compare whether the sorted strings are equal or not. But what will be the time complexity and space complexity in order to do this? If both the strings are, let's say, of n size each, I'm assuming both the strings will be of same size, then only they will be anagram. Otherwise, if two strings are of different size, how can they be anagram? Because we have to rearrange them to make them equal. But if strings are not equal length, how can they become equal? So if both strings are of, let's say, n size each, so sorting the first string will take n log n time. If you are applying the most optimized sorting algorithm like merge sort, quick sort, or something. And similarly, second string will also sort in n log n. And then to compare both the strings, whether it is equal or not, it will take linear time. So overall time complexity will be n log n plus n log n plus n. And if we are using any sorting which is in place, so space complexity will be constant. So time will be n log n, but space will be constant. Is there any better solution than this? Can we do it in constant space only, but maybe in linear time, even lesser than n log n? Answer is yes. See, what we need to do. If two strings are anagram, let's take the same example again. AA, BB, CC, EE, DD. Second string is ABCD, ABCD, EE. If these two strings are anagram of each other, can I say all the characters which are there in first string will also be present in second string in same quantity, in same number? That is, if there are two A's, there should be two A's in the second string. If there are two B's, there should be two B's in the second string. If there are two C's, there should be two C's in the second string. Two D's, again two D's. If there are two E's, there should be two E's. Every character should have same frequency in both the strings, and it should not happen like one character is present in the first string and different character is present in the second string. It should not happen. So if both the strings have same frequency for each character from A to Z, then both strings will become anagram. Because if every character will be equal number of times, there will be some rearrangement possible to make them equal, to make them just comparison wise, make them completely equal. So the better solution will be to count the frequency of all the 26 characters in the both the strings and then compare the frequencies of all those 26 characters. If all those 26 characters have same frequency, then answer is true. Yes, the strings are anagram. Otherwise, answer is false. And how to figure out frequency of each character? You can create a hash map that is a key value pair where key will be character, value will be frequency. Or you can also create a frequency array because the size will be only 26. There are only 26 types of characters possible, only lowercase alphabets. So better will be a frequency array because it will be easier to implement and it will be easier to code. It will not require any hash map knowledge. So let's just now directly jump onto the code part where we will use the frequency array. Although there is a frequency array, it does not mean it will take linear space. It will take constant space only. Why? Because as told right now, both the frequency arrays for both the strings will be of 26 size only. That is, both the strings can at max contain 26 different types of characters. So space will be constant, but time will be linear. That is, we are able to run the loop over the strings and just count the frequency of each character. So what we are going to do, create a frequency array, let's say F1 for string S, of 26 size. So we are going to create a frequency array means a integer array, a frequency integer array. Similarly, create a frequency integer array for second string, let's say F2 for string T of 26 size only. Both the frequency array should be of same size. You can also do it using one single frequency array that can you can take it as a follow-up, but I will be making two different frequency arrays for both the strings. Now we can run a loop over all the characters, run a for loop over all characters in string S and just do the frequency for that character plus plus. That is, as soon as we are able to get a character, we will do the frequency incremented by 1. So frequency F1 of the character, we will do the frequency of character should become plus plus. Set it to plus plus, make it plus plus. But since we are using a character array or a frequency array, actually not a character array, but integer array, the indices will be from 0 to 25, but the characters uses ASCII codes, which are from 97 till 122 for small a till small z. So in order to convert 97 to 0 and 122 to 25, that is small a should be stored at the 0th index, the frequency of small a. The frequency of small b should be stored at the first index of the frequency array. Frequency array's second index should store the frequency of C up till Z should be stored at the 25th index, the last index of the frequency array. Frequency array will be of 26 size. But the SKI code of A is 97, B is 98, C is 99, up till Z is 122. So the point is, whenever we are getting a character, we will just subtract 97 from it. Subtract 97 from it to get the index. 99 minus 97 will be 2. 122 minus 97 will be 25. And what is 97? 97 is actually the SKI code for A itself. So we can just subtract A. So what we will do is, we will not do frequency of character plus plus, we will do frequency of character minus A plus plus. That is, we will go to the corresponding index for that character, and at that index, we will do plus plus. Same thing we should do for the second string, that is run a loop over all characters in string T and do the frequency of character plus plus in F2. In first case, it is F1. In second case, it is F2. And now, once we have the frequency for both the strings, for each character, we will compare for all the 26 characters. So run a for loop over all indices 0 till 25, that is from 0 till 25, and compare. If the values are not equal, then return false. Otherwise, if all the values are equal, then return true. So after the for loop, we will return true. So if frequency 1 of the current index is not equal to frequency 2 of the current index, we will just say return, then return false. That is, both the strings are not of the same, you can say, same anagrams. They are not anagrams of each other. So return false in this case. Otherwise, if all the characters have same frequency, return true. So this will be the instruction manual for the problem valid anagram. We will be writing the code for the problem, find if one string is anagram of another string or not. So what we are going to do is, we are going to create frequency arrays of 26 size for both the strings. F1, let's say, is for the first string S, and F2 is, let's say, for the second string T. So F2 is also of 26 size. Both the strings or both the arrays will be of 26 size, because the input was only containing strings having lowercase English alphabets. Now we can just put the frequency by running a loop over all the characters in the first string. That is index 0 till index less than string dot length, and we can say index plus plus. And for the frequency of the character, what we have to do? First, get the index in the frequency array, that is F1 of the character S dot caret index, the character minus the A character. Why? Because if character is, let's say, A minus A will be 97 minus 97, which is 0. So frequency of 0 will become plus plus, because A is stored at 0th index, B is stored at first index, and so on. We have already discussed this in the approach video. Same thing we are going to do for the second frequency array. So we will run a loop for the second string, run a loop over all characters of second string, and just do what? We can say, this time the character will be taken from second string and frequency will be second array. So T dot caret index minus A character, that is again corresponding indices will be shifted by minus 97. So let's just for now print both the strings, or not strings, but both the frequency arrays by using arrays dot toString. This is the function name to print all the values of a given array. So I will just first print the first string, and then comma separated, I will also print the second string. And for now, let's just return true in the last, so that there is no missing return statement error. So if I will run this, hopefully for this sample test case, anagram, nagaram, frequency arrays should be exactly same. So you can see 3, 0, 0, 0, then 1, then a lot of zeros. Same here, it is 3, a lot of zeros, then 1, a lot of zeros. So both the frequencies arrays are same for two strings which are anagrams of each other. So we can just now compare for all the indices whether the frequency array values are same or not. If it will be same for all the indices, that is from 0 till 25, their answer is true. But if any of the value is not same, if F1 of index is not equal to F2 of index, then we have to return false, that any one character is not having same number of occurrences in both the strings. So if I will run the code again, let's see if it is working fine or not. So in which test case it will return false? If I am taking, let's say, first string as having triple A 2 times B, but second string is having 2 times A triple B. We can't just rearrange the first string to become second string. Why? First string have A3 B2, second string have A2 B3. So any one character, if frequency is not equal, the strings are not equal, or actually strings are not anagrams. So let's just remove this print statement and submit this code for now, or maybe first let's run it and then we will submit it. So let's see if it is working fine for sample test cases. It is, and let's now submit it. So hopefully it should work for all the test cases, all the corner cases also, as we have already discussed. And just to have a minor update or minor optimization, you can just first compare whether the strings are of same size or not. If strings are of different size, just directly return false without even doing anything. That can be a small optimization. But as already discussed, these two frequency arrays are of 26 size, so constant space, and these two loops are on the strings. If both strings are of same length n, so both the loops will be of order of n. The third loop will be 26 only. So overall time complexity will be linear, order of n. So time linear, space constant. This is the solution of checking the two strings are anagram of each other or not. With that, we are done with this problem. We will meet in a new problem, with a new problem actually, in a new video. Till then, bye bye, take care.